Welcome everyone to Science in Action. Today is Tuesday, May 11th, 2021. We look forward to hosting another Science in Action with you all here on the call, as well as those of you that are watching this on YouTube. This week, we're very excited to invite Dr. Matteo Cavalleri. He's a publisher at Wiley and here to talk to us about from studying chemistry to publishing chemistry. Matteo, it's all yours.
So thank you very much. Thank you for having me. I'm kind of excited to be with you, but also a bit scared because I look at previous talks posted on YouTube and were really fantastic. So I hope I do not disappoint you. So I was asked to share my educational journey. This is actually not particularly interesting or particularly unusual. But this talk is also about a journey, not only my personal journey, but the journey of science from the lab through journals to the general public. Mine is really quite unremarkable. So I studied chemistry in Italy with one semester in Spain. In the European Union, there is something that is called the Erasmus project, which allows basically any student to spend a semester in a university in another European country. And so I chose the University of Valencia in Spain. And that actually was a motivation for me to really go out and discover the world. I mean, these are two very large universities. So with 60, 70,000 students each, both of them. But I was actually living already with my family very, very close to the campus in Milan. So I really went out and see the world in Valencia, and there is where I discovered that I really wanted to make a journey physically, not only in science. And I moved to Sweden for my PhD at Stockholm University. And what I studied is quantum chemistry or computational chemistry, which is basically computer simulation of chemistry. I put very small in my presentation the Stanford logo to give me some East Coast street cred with you. My co-supervisor of the PhD got the position, so moved from Stockholm to Stanford at the very end of my PhD. So I spent 3 months over there. After my PhD, I moved to a lab in Germany, in Berlin, where I kept doing computational chemistry, and I was studying through computer simulation catalytic materials for the chemical industry. And at a certain point, after 3 years, is where I moved to the other side, and I moved to this large publishing company called Wiley. I would say that my motivation for do that I will slightly talk about later. But from there, I really cover different roles. At the beginning as editor, I will explain later what an editor of a journal does. Culminating for being the editor-in-chief of the International Journal of Quantum Chemistry for 8 years. And currently I have the position of publisher, which essentially means that I manage the US-based editors for all the journals in physics and material science, such as those presented, for example, here. And so I work for Wiley, which is one of the three largest commercial publisher in the academic space. Interestingly, it was born as a fiction publisher. It was the publisher of Melville, of Moby Dick's fame in 1807, but really moved into publishing science and engineering in the mid 1800s. And today, still there, is one of the largest. Wiley published 1,700 journals in all gamut of covering the entire gamut of all the science. and 7.5 million research articles are sort of hosted on our website. And as for everybody else, actually, I would say the office is still in the New York City area, and I'm working from, you see my desk now from the other side, from my home in Brooklyn, New York. As I say, my journal isn't particularly remarkable in terms of education. Most people who have done a PhD tends to move around and move around even different states in the US or countries. This talk is also about another journal, which is I think more interesting, which is of the science from the lab where it's done to other researchers and eventually the world, right? Because what happened is science, 21st century science, no matter if it's done in space or in a lab or out in the field, then comes out as a journal publication, as an article publication, essentially, right? And this is still true. But the one thing that is interesting is that when you are a researcher, when you are doing the research in the lab, that part that is fundamental, the part of publishing the aspect of publication of your science, which is the way how other people knows about it and can stand on your shoulder and advance science thanks to your results. But it's also very important for somebody's career because hiring and promotion are determined by your publication. It's really a black box. Nobody seems to ever really have an idea of what's happening. And the first time that you, as a grad student, you send your article to a journal, you know that it will come back a few weeks later with some degrees of criticism, but you don't really what happened. You don't know what's happening inside, right? By the way, it has always not been this the case. In fact, science was actually not really shared consistently until 1660s or around. I mean, there is really tendentially scientists of the past were discovering something that keeping them for yourself or for themselves or in the inner circle, right? For example, the two handsome guys that you see there, Tartaglia and Cardamom, were actually fighting over getting in the 1500s about getting a professorship position in a university in Italy. And what happened in those cases was that Cardamom had solved the cubic equation, so it's an algebra equation. Tartaglia wanted this job, and so Cardamom said, okay, these are the equation I solved, see if you can do it. But he hasn't told anybody how I solved this equation, because that was not the case. You were really keeping it to yourself. Niccolò Tartaglia ended up solving this equation, so sort of getting Cardamom job. And in a certain sense, he did publish the results, but in code, in the form of free poems. So not really for the general public. The idea of opening shared scientific ideas really became common in the late part of the 1600s. Like there is Boyle's Skeptical Chemist is a book which is really about the transition from alchemy to modern chemistry, but it's also the first example of chemistry publishing, right? Scientific publishing in the sense of sharing the science that people were doing, it really began officially in 1665 with the launch of two journals, the Philosophical Transaction of the Royal Society in London and another journal in Paris. Interestingly, those 17th century articles really looks like exactly how they look now. So there are words, and then there are drawings and illustration, like the one you see here, where there is a chimney for mining and a calf with an interesting head, right? So nothing that really changed it. Really was the 1950s that marked the growth explosion of science and scientific publishing. And as science professionalized, so scientists were sort of paid to be scientists. They were not like rich aristocrats that were doing that as a hobby. So became academic publishing, and so commercial publishers like Wiley now are growing to dominate the industry. A sort of nasty side effect of scientific publishing in current times is that because most hiring and funding decisions are based on the publication record of researcher, it sort of caused this publish or perish mentality or culture, where now essentially there is an overabundance of scientific publications because they're really necessary for advancing career. So what do journals do, right? You probably have seen in your study articles in scientific journals, but what really scholarly journals do today are 4 different things, right? They do dissemination, so they spread the word of the science made through publishing platforms and the journals. They do the archival part, so they do safeguarding and preserving of knowledge from the past. In the case of Wiley, of articles and science made in the 1800s. They also perform registration, so basically who has done what when, in terms of, especially in very competitive field, or if you want to establish a patent, or that is very important. But these 3 things, if you think about it, can also be done through the internet, right? You don't really need now a journal to disseminate your science. You can do it through a blog or a YouTube channel or something like this. And so the main role of scholarly journals today is certification, is the what is called peer review, that we'll explain, that is still the gold standard for certifying articles, right? And as I say, unfortunately, the publisher parent culture will really make a lot of emphasis in publishing your research in the most prestigious journals, made also those prestigious journals the de facto gatekeeper of science. And this is something that sort of the academia and the industry is now working to change a bit, right? Just so that you know, because you may have encountered this definition before, scholarly journals are essentially fall in 2 different models. One is through subscription. So essentially you would have a university or a college library subscribing to the journal. And so this is how you read it, through the publication, through the subscription paid by your university or college library, or open access journals where the articles are freely available online, so there is no cost for readers, and normally are the author who sort of pays the journal upon publication. Right? I talked about a bit before this certification, this peer review, and essentially the official definition is the critical assessment of a manuscript submitted to journals by experts who are not part of the editorial staff. Another way to put it is peers of the author, other experts, other researchers in those fields, right? The editorial staff is people like me, editors, and our job is to, a bit to do some filtering, but essentially to select the right experts to assess the manuscript. Again, we actually how did we get there? Again, the story starts in 1665 with the publication of these two first academic journals. However, there wasn't really an assessment there beyond the editor of the journal. People were sending literal letters, literal manuscripts to the journals, and the editor was sort of deciding, okay, this is worth of publication or not. Peer review, as I defined it before, really emerged in the 1930s, 1940s, and wasn't really popular at first, right? This is, I love this. So Albert Einstein had this response to the editor of Physical Reviews, which is sort of one of the most prestigious physics journals published in the United States, and basically said, I do not really care about this comment by your so-called expert. I just sent you the paper to be published. Don't waste my time. Really, peer review became institutional standard, meaning that every journals and every article in the journal go through this process, really not before the 1960s with the journal Nature. And today, really still enjoy overwhelming support, despite some issues. I mean, first of all, is slow down the diffusion of science, right? Between scientists spend time in the lab doing their experiment, their research, then they write the article, and the article goes out to a journal. The editor has to assess it. The reviewers need to assess it. This can take weeks or months before the paper is eventually, if you're lucky, published. If not, sort of sent back to the author for the revision. Peer review is also systematic biases. I mean, in a certain sense, we know, we have data that it does favor scientists in the West, and sort of the status quo is make more difficult for science from a likely place to emerge, and it doesn't even completely filter out fraudulent papers or simply sort of wrong, deeply flawed science all the time. So there are a continuous experiments and alternatives and iteration to try to improve this concept of peer review. So that you know, there are three common types. The most common is called single blind, where the reviewers, so the external expert, are aware of the author's identity, but not the other way around. So the authors receive anonymized assessment of their papers. This was the anonymous expert Einstein was making reference to. This is because sort of to protect the peer reviewers from some sort of revenge of the authors when the table turn and the reviewers become the author of a paper that is sent to the reviewers who may be the authors of the paper they have assessed. Right? Double blind is also where the authors' identities are hidden to the reviewers. So the editor stripped down any information about the identity of the author to send this to the reviewers. This we know that is actually decrease and mitigate some of the biases because really the reviewers have to focus now on the science contained in the article rather than the identity of the authors. But there is any sort of variation, including triple blind, where nobody knows who anybody else is, or open, where all the identities are known. And as I say, peer review is very much supported, but it's also need of innovation still. How does it work? So what is the journal of science inside an article? I told you that this is a slow journey, but how does that, right? The author submit the article. The article is assessed by the editor. The editor can choose sort of to reject the article, to send it back to the author and not proceed further with the publication. This may be because the editor believe that there are some flaws, or the articles, for any reason, scope or length or lack of clarity, does not belong to the specific journals. But otherwise, send the paper to the reviewers that who has the editor has selected. The reviewers then have a few weeks to assess the paper. The referee reports, how they call, so the assessment of the reviewer is now then considered by the editor, who then take decision on what to do with the paper. Right? I will later a bit tell you what the possible decisions are, but I want to make an important distinction about who are the editors. There are essentially two ways academic journals are managed. There is what we call, and this is sort of my job, what we call in-house editors. These are former scientists, all with PhDs and postdoc experience, who have left academia to work full-time on the journal. So in this case, we can dedicate essentially more time and resources to assessing the paper and reading the papers. We also tend to have a more general view rather than really be the sort of world's top expert on something very specific. There are other journals who have what I call here external editors. So in this case, the editors are active scientists at universities around the world. So they have their own research group, they have their own teaching duty, so they do this part-time essentially, but they are the really expert in a specific team, a specific field, often at the very top of that field. That being said, their role are exactly identical. What the editor does is to manage the peer review process, which means selecting the reviewers, making the decisions on whether the paper is going to be accepted or not for publication, dealing with appeals, and more in the case of in-house editors than external editors, for example, also contributing to news story press releases on particularly important articles that are published. I say, what are the decisions that an editor can take? They're essentially three, right? Hopefully, acceptance, which is the paper is accepted for publication and therefore appear in the journal to then be sort of read and enjoyed by fellow scientists and the public. Most likely, the first decision is revision, so some sort of request for revision to the author to clarify some aspect of the paper, or to add further data to make sure that everything is correct, or the rejection of the paper, which means that you communicate to the authors that the journal does not consider their article, the research, for publication, and that normally move the author to another journal with different characteristics. What I can tell you is that this is not how it works. If you are, when you write your first article, you really see yourself sort of fighting with these peer reviewers, or also called referees, with the editor sort of enjoying the fight and then declaring a winner at the end. This is not really the case, and my point, and what really drove me to make this journal and this jump from active research to publishing, is that really the editor is part of the process and is a very important part, because really take the concern of the peer reviewers and the excellent science of the authors and try to merge them in a manuscript that is, clearer, stronger, and more solid than when it's published and when it came in from the first time. So I mentioned before, I studied in Europe in 4 different countries, and I studied chemistry, and I had pretty much sort of a standard trajectory for somebody who aim for a higher degree in physical science. What happened was later, when I got to be a postdoctoral research, it also was very clear to me that research wasn't for me. I was very, very interested in discussing science. I was very, very interested in telling people about science. I was very, very interested in the great ideas, but really I didn't care much for doing science in the laboratory. I was really more interested in the sort of more abstract concept and really the dissemination. I love to talk about my science, and I love to hear about what other people were doing. And so really at a certain point you're looking for a job, and you ask yourself, how can I stay in science, which I do love, and I do love the environment, the very international environment, the very diverse environment, without staying in academia. And so I had my eureka moment, which was not really an eureka moment, but more a sort of slow burning process, informed, by the way, by a lot of networking and a lot of discussion with people that were already in this type of profession, and I got into STEM publishing. So what do I do when I jump on the other side, right? Yeah. The bulk of the work for an editor is really the day-to-day management of the journal. So imagine one editor, in-house editor, so full-time, dedicated to that, assess approximately 1,000 to 1,200 new manuscripts per year. So 3 or 4 new manuscripts, new article per day. You read them, you assess them, you identify and assign manuscript to the reviewers, so to the correct experts. Based on the assessment of these reviewers, the editor takes the editorial decision or to accept the paper for publication or not. We also invite people to publish actively in our journal if we think that their science is really exceptional, and really do also spend a lot of time dealing and resolving ethical issues regarding submitted manuscript or publishing papers, because, as I mentioned before, there is a lot of pressure on researchers to publish. I mean, their career may depend on them publishing, and so there is a bit of, in some places, an incentive to cheat, really, right? That is now built in the reward system of academia. So we need to be very, very careful for that. We also do outreach, which means that we help authors to disseminate the work further through, for example, writing press release or news pieces of the articles. And we also attend international conferences to stay up to date with the science, but also to talk to the science in person. And I also do a lot of workshops, especially on how to write scientific articles around. Now, as I say, I sort of grow after 10 years in this industry, and I'm the publisher, which essentially means that I'm a group leader. In the specific case, I manage the editors that are based in the United States and work on the physics and material science journals of Wiley. And what is really cool about it is that international feeling that you have in an academic lab is also reflected in academic publishing. So my team includes people from 6 different countries. What I also do is sort of rolling out new publishing initiative. For example, the decision of launching new journals, whether if that is needed because a new branch of science is is really taking off and will need more outlets to publish. I also deal with the finance related to journals. We normally, editors do not deal with the finance of the journals because we don't want the assessment of the science to be sort of influenced by financial performances of the journals. We don't want an editor to feel that the pressure or the incentive to publish more papers, even if they are not according to the standard of the journal, because there are some financial issues in the. And also, the job is really to hire, train, and managing this author, plus making decision on the launch of new products. What is really good and interesting is that scientific publishing, as it is not really restricted to people with PhDs. I mentioned before that most journals are actually have academic editors. So editors that are still active researchers and professors at universities. In this case, within a publishers like Wiley, there is somebody who's sort of support the academic editors, but do not take, so in terms of especially of liaison with the production team who actually then typeset and publish the articles, or with the marketing team, but it's really somebody who's there to support the editor-in-chief, who make the assessment of the journal. So this person doesn't necessarily need to have PhDs. Most apex titles, as they call it, so the most prestigious journals do also have, they do copy editing, so people that do proofreading and improving of the language in an article that is accepted for publication. These are normal people with master or bachelor level science who really love language. So you need to have some scientific understanding of what is the paper is about, but you do not need PhDs, and there are also opportunity in what we call acquisition. So people that is really more responsible of inviting scientists to publish articles or special issues in a specific journal, because we believe that this journal should publish a bit more of this sort of branch of science, or we really think that this particular science is so awesome that we want their research to be published. And this is somebody who basically do that. I think you get from my voice that I really like what I do. And as I mentioned, the reason why I took this journey was because it's really a career at the center of science. In fact, if you think about it, right, somebody in a lab somewhere make an amazing discovery. As the editor, you are the first person outside that lab to actually see those results. I also really like the constant contact with the scientific community, because we talk every day with authors and peer reviewers, and really the opportunity to participate in the scientific debate and the progress and the destination of science without actually the boring lab work. Some as I say, I mean, journal development, especially if you want to launch a new journal, can be slow and frustrating, but in a certain sense, the entire process of peer review is slow. And this is something that sort of put a lot of pressure on us. Obviously, authors that are what science is rejected are not really, happy at the moment when the decision is taken, and they take it on us. And I mentioned before, there are a lot of incentive in publishing and publishing a lot that makes ethical violations and fraud not uncommon, and they're very exasperating when you have to deal with it and sort of try to prevent. It is really, though, a job for somebody who's really passionate about science communication, that recognize the importance of, communicating science, not just to do it, and the importance of publishing through that. I think what is really cool is that you need to be curious about a wide range of topics and disciplines, because, as I mentioned before, if I assess 1,000 new scientific articles every year, each article will be slightly different, right? And so, on a certain sense, you also need to be comfortable to get out of your comfort zone and try to learn always new science on the go. And as I say, and so if you are a specialist, not a generalist, and you don't like sort of changing topics several times per day, maybe this is not a test for you. And I always actually ask when I interview people, whether if the candidate like to write their master or PhD thesis, because it's not only about, this journal is more about the communication of science through written text, rather than actually the actual making of science. It is painfully clear from my accent that I know, I'm not a native speaker, and English is the language of science. But I mean, the majority of authors now, the majority of scientific articles that are published around the world are from people who are not native English speakers. So publishing, this is not a problem for you guys, but I always like to say that publishing is really not restricted to native speaker anymore. In fact, if you want to represent and reflect and mirror the scientific community, you have to have an international editorial team in a journal. Obviously, you need to be sufficiently fluent in English to communicate science with it, but this is not a problem. I don't know how much time I sort of used, but I hope I gave you an idea of my journey, both personally and the journey of science, from the lab through journals into the public. And really, my message is that I do not regret having taken this journey, and I look forward to your comment and and your questions.
Thank you so much, Matteo. Really, really appreciate you sharing not just your journey, but also really good perspective into your current work as a publisher. So I did manage to take hold of all the questions that were posted in the chat during your presentation, but I also want to encourage any participants that are currently on the call to post some questions, because I think we have plenty of time. I mean, it's 5:09 right now, so we have until the bottom of the hour for us, but I'll go ahead and move through the questions chronologically. So earlier on, when we were talking about the early stages of publishing, we had a question pop up in the chat. Are the articles from the 1800s being digitalized and available for open access now?
So no, actually, I mean, so the articles are digitalized and available since 1665. So you can find the sort of the first articles of the proceeding of the Royal Society. Whether they're open access or not really depends from publisher to publisher and from journals to journal. So they may be available through your library in some cases. In some cases, they're available to everybody. But yes, all the articles since the 17th century are now digitalized.
Thank you. Thank you. So I'll move on to the next question. You alluded to it throughout your presentation, but it's worth kind of mentioning and checking in on. How long does the process of getting your paper accepted for publication take normally? Maybe like go ahead.
Yeah, it also that depends, but I would say that is at least a 2 to 3 months journey. It can be faster if you send it to a journal who really want it, and it's something that excites the peer reviewer enough that they will stop whatever they are doing, which is normally their own science, to read it and assess it. Can take 2 weeks, but I think most commonly is 3-4 months. And in some cases, you have to consider that the journal the article may be assessed by the reviewers, but then the reviewer reject it, so they recommend the journal not to accept it for publication, which means that you are back to square one, revising your paper and sending it to a new journal. So in that case, can take longer. I mean, there is one, the article I'm the most proud of from my PhD took 1.5 years from sort of completion to coming out somewhere. And this is, by the way, when I mentioned, so this I think came out especially this year, right? With the COVID crisis, there is a lot of scientists that sort of stopped doing whatever they were doing and start working on either a cure or a vaccine or anything related to COVID. And then they find out that they had these things, and then they were going through journals, and it took 3-4 months to move while this is going on right now. And so I think there is a lot of work to do there. You want to have that certification, that stamp that somebody has looked and this is not incorrect and is not completely crazy and is not exaggerated. But also sometimes if you don't have the time to, the world doesn't have the time to wait.
Mm-hmm. Mm-hmm. Thank you. So we did have another question pop up into the chat. This one goes, thank you for sharing a typical day in the life of a Wiley publisher. Have these practices changed due to the pandemic and normalizing the work from home practices? And any changes that you would prefer to remain permanent? And any other changes that you prefer not to go through again?
Well, I mean, so you can probably easily imagine that this is a job that you can do anywhere, right? Because really people now send you digitalized version of your article and you read it and then you send it by email to or some other platform to somebody else. So moving completely remotely didn't actually change much because it's something that we can really do at home. And prior to COVID, we were doing it, from hotel rooms when we were out at conferences anyway. I do miss the people. So in my job now, especially, I work with a dozen scientists or former scientists from 7 different nationalities, and these are all sort of interesting folks, and each one of them is a specialist in some different aspect of science, and that kind of interaction is difficult to reproduce even by scientists and by Zoom. And also we don't have to forget that science is made by people, right? And so there is a lot of that we would like to keep, and I think we will, places like Wiley, we will be less strict in having people to relocate. So if you want to do it from Wyoming, you can probably now do it from Wyoming. It will extend our pool of talent. But you need some sort of, I need some sort of in-person interaction with people sometimes.
Yeah, definitely. I can very well resonate with that. Science comes from people originally, and you want to interact with them. So we do have another question that came up. Do you recommend any helpful resources for folks who aren't doing so well in chemistry? It's a little bit specific question this time.
So I don't know, but I also because I sort of cheated here in talking about chemistry, but really I slowly moved in my academic career towards physics more and more because I was better at it. I do like, I admire chemistry in terms of what they can do. The chemists make stuff, but they don't understand half of what they're doing, and I like to understand. But let's say that doesn't answer your question in any way. Yeah, I don't really know. It's also what's your problem with chemistry? I mean, yeah, we should have a longer conversation maybe about exactly what is that that is the obstacle here.
Yeah, and I'm gonna shamelessly plug in tutoring services are available online. Feel free to message me if you want to get connected with any tutoring resources that are available at Skyline College. We're happy to help.
That's a much better tip than whatever I try to be.
So I'll transition to the next question here. This is more of a personal one. Do you have a favorite article or a favorite type of article to read in your line of work?
Yes, actually, I do. I really like pedagogical articles. So what in the journal I used to work on, the International Journal of Chemistry, we used to call it tutorials. This is kind of solve the problem of really sharing science. So one of the issue I would say with scientific publishing is that people share their successes, right? So you go in a lab and you fail 1,000 times, and then you finally get it right and you publish that, right? Which is cool and everything. But then when you are a new grad student, you go in and you fail 1,000 times, and sometimes it's not been necessary because somebody else has already failed 500 times. And if you only knew, you could save yourself and science a lot of time. So I like this kind of articles which are maybe less exciting because they have more failure than successes. But they are important. So these I kind of enjoy. They're also slightly more honest, right? Because it shows science really how messy it is, rather than, oh, I've done this, and look, it's cool. Yeah, it took you 3 years to figure it out, but okay. So this is what I particularly I think enjoy reading. And
absolutely. Thank you. So the next question that came up, just out of curiosity, what percentage of submitted articles are rejected on average?
So it very much depends, right? As I mentioned before, there is this there is sort of this weird, I think slightly wrong reward system in place in academia, where publishing articles in certain journals is really what make or break your career, right? So these are the so-called high impact journals. Right? So everybody wants to publish in those, and they have 95% rejection rates. So they publish 5 out of 100 papers that are submitted to them. The journal I worked in, the International Journal of Chemistry, we had a 40% rejection rate. Which is a bit less, but it's still sort of almost half of the papers they had to go through multiple revision or go to other journals to be published. So, yeah.
Let's see. Moving on to this question. This is interesting. How do you see your role and that of your field growing and evolving in the upcoming decades?
So I think that, so this is a very good question. I kind of hinted to it in my presentation. So what we call the scientific article, so the way that science is disseminated, looks like exactly how they disseminated the science in the 16th century. It's a lot of words and static figures, right? So we publish, now a scientific journal published 21st century science with a 17th century technology, right? And if you've been around the internet, you find out that there are a lot of better ways to visualize, for example, data in terms of interactive 3D virtual relationship, but also the fact that those figures only tell you a slice of the story of the data. And so really the integration between the article and the data below, the raw data below, it's more important, and also make the science way more reproducible, because now we are not just looking at 4 points in a line. You can say, okay, these 4 points is because these are all the gigabytes and terabytes of data that these people have submitted. And so let me check exactly what they've done, or what if I change this with this in the analysis, right? And so we are starting to do that. So we have what is called interactive and executable article. But I think there is a lot of work to do to bring scientific publishing out of the 17th century in terms of technology. And the other thing is peer review, right? Also that is not that long, but it's around in a form or another from 1930s. And we know that there are structural biases in the system. And so how to open up peer review is another aspect which I think a lot of publishers are looking at.
Okay, interesting. So I'm approaching the last question that I see in the chat. So I just want to encourage any other participants that are still on the call to post any questions that they may have. Send it to the general chat, or you can send it to me as a direct message, either way. But the next question comes in, what topic in chemistry do you feel is important and should have more articles / research done on that tends to get overlooked? And we can just broaden this outside of chemistry as well, physics, any kind of field that you think could get a little bit more attention.
Well, so I think there are two different things in this. So what is really important in the sense that is really changing the direction of chemistry is artificial intelligence. So right now, especially in a field like mine, which is computer simulation of chemistry, having sort of other way to discover materials that is not human intuitions can really help a lot. And it's new, but it's really growing, and I think it's changing the way people is doing chemistry. What is overlooked is, in general, I think in all the physical sciences, ethics. There isn't much of this in the journey of a researcher. There is almost no ethics. So we do science because it's cool. We do science because we think and hope that it will advance the world in a positive way. But very rarely somebody stop and think like, should I do this? What are the consequences of putting this drug out? Or, I mean, the classic example, obviously, in history is the atomic bomb, right? It's does the nuclear physics, didn't lead only to that, but it also led to. And so that is definitely overlooked. I see very, very little papers on that. There is also another things which you start to see more, which is really the carbon costs of doing research. So people start to compute and estimate what is the carbon cost and the environmental cost to do certain experiments. Because it may cut out the number of unnecessary experiments that are done in a university setting, because yes, you may learn something, but you are also destroying the planet, so maybe you should do something else.
Understood. So we did get one more question in the chat, and this will be our final question in the consideration of time. We have about 4 minutes left. So this one, has there been an instance where you accepted 2 articles with contradicting or conflicting results? And then how would you rectify them?
So yeah, no, the answer is, I mean, as I said, in my work, I assess 1,000 manuscripts per year I've done it for 10, 11 years. So, 11,000, 12,000 articles. So there were definitely some of them which were conflicting. Now, this is actually cool. I mean, this is how science advances. It's how you reconcile it very depends on the fact that if they come at the same time or not, for example, because the most common case that you accept the paper and then somebody write another paper and say, actually, I have done the same things and I don't think the conclusions are correct. And in this case, you assess it as new. You possibly look at the same reviewers and say, well, you have looked at this before and you approve it for publication. Can you have a look at this? Does it make sense? And then if it goes out, it's out, and the scientific community will then sort of build and develop. There are certain cases where the papers are coming at the same time, so none of them is published. And in this case, I mean, we have taken different cases. In some cases, we really went back to the author and say, listen, why don't you guys talk to each other and write one? Because I think will be better, and there is probably a lot that you can learn from each other. There are also some cases where they lie, say, no, we literally hate each other, so we won't do that. And in that case, again, sort of we try to assess them individually. But if there is a concern that come out from a paper that says, this analysis seems to be incorrect, and this is also what the other paper is saying, that's maybe shift the scale and you only publish one. But yeah, there isn't a general rule, but these happen all the time.
Understood. All right, so we are just about to hit 5:30, so I'm going to take a moment to thank you, Matteo, so much for spending this afternoon, evening with us for Science in Action. You'll be able to catch this recording on YouTube as soon as we finish the editing, and then we get approval for publishing, and then we'll make that available to all of you. Matteo, thank you again so much for sharing your educational journey and then your current work.
Yeah, thank you for having me, and yeah, this was fun for me. I hope also for you. Okay, bye-bye.